Hello ladies and gentlemen, welcome back. Glad you could make it. I'd like to welcome you to remote learning lesson number 5. We're into the solving quadratic equations module, and in this lesson we will be looking to solve quadratic equations using square roots. First thing we need to look at is the square root property. So we know basically when you start like with the square root of, like 49, we take and we know the square root of 49 is 7. And we're going to go with positive 7 because that's our principal square root. Now we've got like x squared equals 49. And we go ahead and we square root both sides. We can say, yes, x equals 7, but we're not totally done. We also have to consider the negative 7. Because 7 squared is 49, and negative 7 squared is also 49. So we have to consider positive and negative 7. The typical conventions of math. We write it as x equals plus or minus 7. So when we're solving equations using the square root property, first thing that we're going to do is we're going to use SADMAP or inverse operations to isolate the x squared term, or if it's in vertex form, that x minus h squared term. Then the next thing we'll do is we'll go ahead and square root both sides. And because we are solving for x, when we square root both sides, we have to apply that plus or minus to both sides. Then if there's any other terms, we'll go ahead and isolate those and solve for x. So when we're looking at the square root property, we need to consider the types of solutions or roots that we're going to have for each of these quadratic functions. So first thing we need to consider is the fact that any quadratic function is always going to have two solutions or two roots. But the zeros or the x-intercepts, those may be different. So our solutions are always going to be either real or imaginary. You're either going to have two reals or two imaginaries. You can't have one of each in this case. Now, the two real solutions can be broken up into rational. Remember, the irrational are ones that we can write as a fraction, or irrational. So our first option, two real zeros, two real solutions, two real places that it crosses the x-axis. And like I said, those can be rational, they can be whole numbers, they can be fractions, or they can be irrational. They can be things like the square root of 17, but it still crosses the x-axis. So you have two zeros and two real roots. The next, kind of a special case one, it does have two solutions, but it only has one real zero. Those are going to be our perfect square trinomials. Those are the ones that either sit on or hang from the x-axis. So it'll have one zero, but the solutions, they'll be identical, kind of like doubles. So we say that 1 0, but double solutions. And once again, those will be rational or irrational, depending on how we solve the equation. Next thing we're looking at is two imaginary solutions. Two imaginary solutions have no real zeros. So these are the ones, the graphs do not cross the x-axis, but it does have a solution. It does have a root. So that's where your vertex is above the x-axis and your a term is positive, or your vertex is below the x-axis and your a term is negative. And those will be our two imaginary solutions, no real roots or real zeros. So, first example, ladies and gentlemen, 3x squared equals 75. Using inverse operations, going to go ahead and divide both sides by 3, resulting in x squared equals 25. Square root both sides, giving me x equals 5 and negative 5. And remember the typical conventions of. So on the next one, 9x squared minus 4 equals 0. We'll go ahead and add 4 to both sides to start with, giving me 9x squared equals 4. Go ahead and divide both sides by 9. X squared equals 4/9. The nice part about that, you got a perfect square as your numerator, perfect square as your denominator. So when you take the square root, you know you're going to end up with a nice rational number. It's going to be a fraction, but it's not an irrational answer. Square root both sides, and we end up with x equals plus or minus 2/3. So looking at add example 2, x squared over 20 plus 4 equals negative 5. We'll start this one out by subtracting 4 from both sides using those inverse operations. We end up with x squared over 20 equals negative 9. Now to get rid of that 20 in the denominator, I'm going to multiply by 20, or 20 over 1. Multiply both sides. The 20s cancel out. We end up with x squared equals negative 180. Go ahead and square root both sides. We end up with x equals plus or minus the square root of negative 180. Now, to bring that up into thought bubble land, we have to deal with that negative 180. So the first thing I'm going to do is I'm going to break this up, prime factorization, break it up into negative 1 times 4 times 5. 4 times 5 is 20, times 9 is 180. I've got two perfect square factors at 4 and 9, as well as my imaginary. So that breaks out into I times 2 times the square root of 5, in this case times 3. Multiply all your coefficients together, you end up with 6i square root's 5, or our final answer, x equals plus or minus 6i rad 5. All right, ladies and gentlemen, coming up on example 3. 4 times quantity x plus 2 squared minus 12 equals 48. Let's start this one out by adding 12 to both sides using our inverse operation. So we end up with 4 times x plus 2 squared equals 60. And what you'll notice is this is now in vertex form. So from vertex form, we can use square roots to easily find the roots in the solutions. I'll divide both sides by 4, leaving me with x plus 2 squared equals 15. Square root both sides, leaving me with x plus 2 equals plus or minus square root of 15. Now we need to do inverse operations one more time, subtracting 2 from both sides to get x isolated, or x by itself. Final answer at x equals negative 2 plus the square root of 15, negative 2 minus the square root of 15. Or we can write it all combined as negative 2 plus or minus the square root of 15. Example 4. 2 times 2x minus 1 squared plus 4 equals 16. This case, inverse operation says go ahead and subtract 4 from both sides first. 2 times quantity, 2x minus 1 squared, equals 12. Once again, that's in vertex form. So we can use our square roots to find the solutions from our vertex form. Go ahead and divide both sides by 2. we end up with 2x minus 1, the quantity squared, equals 6. Square root both sides. 2x minus 1 equals plus or minus 6. Excuse me, plus or minus the square root of 6. Inverse operations, again here, adds 1 to both sides of the expression. So we end up with 2x equals 1 plus or minus the square root of 6. I divide both sides by 2. Final answer coming in at x equals 1 plus or minus square root of 6 over 2. And that looks a lot like one of the answers we get from the quadratic formula. Example 5 coming from the honors assignment. This is problem number 6. Start by subtracting 14 from both sides. So we got the opposite of 2/3 x plus 7 squared. And that's going to equal negative 2. And that negative 1, a term that tells me the graph is going to be opening down. So I'll go ahead and divide both sides by negative 1. Negatives cancel out. We end up with 2/3 x plus 7, all of that squared, equals 2. We'll square root both sides. Two-thirds x plus 7 equals plus or minus the square root of 2. Go ahead and subtract 7 from both sides, continuing with those inverse operations to solve for x. So 2/3 x equals negative 7 plus or minus the square root of 2. Now at this point, I'm going to do step by step to get rid of that 2/3. I'm going to multiply by the denominator over 1, denominator over 1, so 3 over 1 on both sides. The 3's cancel on the left-hand side of the expression. So for this, we'll go ahead and we can accomplish the same thing. Subtract 7 from both sides. Now, in this case, once I have negative 7 plus or minus the square root of 2, in this case, I'm going to multiply by the reciprocal instead of breaking it up. So multiply by 3 over 2 and 3 over 2. Left side of the expression cancels, 2's and 3's, so we're left with just x. On the right side of the expression, I'm going to distribute the 3 across the numerator, and the denominator, which was 1, was all over 1, multiplied by 2, so we end up with negative 21 plus or minus 3 square roots of 2, all over 2. Our example number 6, also coming out of your honors assignment. This one stated that when we're measuring televisions, we measure corner to corner on the television to get the size for the television. Now, televisions come in high definition HD or our standard definition SD. The HD televisions come in a 16:9 ratio, so 16:9 length and width. Standard definition televisions are a ratio of 4:3, 4:3 length and width. Go ahead and multiply that out. 16 squared is 256. 256x squared plus 81. Go ahead and divide both sides. So we're at about x squared equals about 8, square root of 8.97. Calculator work, that came in to be about 2.9949. So for the purposes of this problem, let's just call it about 3. Ladies and gentlemen, the answer to this one is, and ladies and gentlemen, that brings us to the end of our lesson today. Make it a great day. I'll see you on the next one.